Hello, this is Team Supra, and we are participating in the Hackathon project, specifically the Pick and Sort Challenge.
I'm Alex.
I'm Guru. I'm Rochan.
I'm Leo.
Here is our model. We manually collect all the scattered plugs with a broom into a funnel, which will further separate them into 5 swarms that will each be directed to a functioning unit. This separation process is achieved through vibrating the funnel, which will first evenly distribute all the plugs and then ensure all plugs can move through one of the 5 ends underneath the funnel. Every functioning unit is connected to a microcontroller, which is also connected to a mother microcontroller. A functioning unit consists of several parts. First, we want to adjust the orientations of the plugs to make sure that each plug is placed either facing up or down. Since all plugs have about the same height, we can use a slit at the end of a vibrating tunnel to achieve the desired outcome. Plus, since the length of a slit is slightly larger than the diameter of a larger plug, this step will give us one of the 6 scenarios. 1. An X large plug. 2. A large plug. 3. A medium plug. 4. A small plug. 5. 2 small plugs. And 6. 1 or 2 plugs that are damaged intentionally. We call each of the 6 scenarios a unit. Second, we need to make sure there is enough space between 2 adjacent units to let our software to work. This can be achieved through a wheel structure that ensures only one unit enters to the next stage at a time. Next, units are directed to a conveyor belt that separates 4 types of plugs. As shown in the demonstration, as a unit enters to this stage, a camera connected to a microcontroller is positioned in a way that's able to receive the size and the height of the unit. We plan to apply a learning algorithm to recognize the unit using those 6 given scenarios. With that, the plugs can be directed to corresponding collectors accordingly. If a unit is recognized as scenario 6, the unit should be directed to a collector that takes all the damaged plugs. The main objective of our software model is to sort the plugs according to their sizes. To successfully determine the size of a plug, we plan to implement concepts of computer vision and machine learning. First, we're going to fix the camera at a constant height and determine the actual length and actual breadth of the image. Second, we will divide the actual length and actual breadth of the image with the relative pixels captured by the camera to get the pixel per metric unit ratio. Third, we are going to calculate the actual length and actual breadth of the object by multiplying the pixels per metric ratio with the number of pixels covered by the object in the image. For this to work, the camera should be set up at a perfect angle of 90 degrees directly above the object. However, considering our practical constraints, we allow a small marginal error. To further improve our method, we are still experimenting on the use of machine learning. We are trying to train a number of classifiers on the images of the different plug sizes and use a vote bank to classify the size. The first method is relatively fast and can detect the size in a few milliseconds. The second method is relatively slow, however, more reliable.